Group 4 code explaining. We're going to talk about all the changes and all the problem we solved and faced. So here is the start of the code, the HCV range value, the declaration for the upper and lower part, and here are the lists. So we changed from while true to while index and the color names. So it's going to loop on the length of the cars. So we can add more color, we can add more end times. Of course, we're going to modify it, so it's going to generate these values, only these values, and nothing else will change. So it's going to be very simple. Here it's going to capture the frame. Then it's going to look for Curtis, the object, the cone. So here's the logic. If cone is detected, it's going to normalize the value, and if the area is less than 6,000, it's going to move towards it. If the area is larger than 60,000, it's going to call the encircling function. For the encircling function, we added this part. A symbol just move a little bit to the right before start the encircling, because on the current code in the current code it used to hit the cone, so we just shifted a little bit at the start and made a little space from the cone so it doesn't hit it at all. For when so while true, check for obstacle. When obstacle is detected, it's going to run the encircling function. Okay, here's the encircling function. So it's totally similar. The only difference is we have a new value, total rotation, and next color yaw, value equal to none. Same as the lab 8 code, no modification until now. When we calculate the difference, we add it to the total rotation. So when the total rotation reach 360, total rotation reach 360, it's going to decrement the counter. So the problem we had here, before we added the total rotation, it used to confuse the previous yaw and the current yaw from the next lap to the first lap. So it's going to increment the X times twice, even though it's still in the same lap, even though it's still the start of the lap. So when the lap finishes, it will decrease the X time, and it will immediately decrease it again. So the encircling function was not correct, not accurate. So this was the solution for the first problem we faced. The second problem is for the if the cone is not in the field of view. So we had to activate the camera inside the encircling function. So when we are at the last loop, and we're in the last loop, get a frame. And if we got a frame, check for Curtis. If it exists, then we just draw the box, and if the area is greater than 1,000, we assign it as the next yaw, current yaw. So it's going to save the value. It's going to save the last value it sees, so it will be at the edge of the frame. So we solved this also, another problem we added, but before that, when it's done, like when it's at this and it got the color yaw, it's going back to the main loop. Before going back to the main loop, it's going to return the next color yaw, because it's less than 1, so the next color yaw will be returned. Go back to the main loop. Now in the main loop, the next color yaw equal encircling, so the return value will be here. If the next color yaw is not none, so it used to be none, rotate to the next color yaw and increment the index. So it goes for the next color. So rotate to the next yaw is very simple code. It's exactly the same as the encircling code. The only difference is instead of x times, we have just to next to the next yo. So it's not going to loop any number of times, just to the next yo. So while true, everything is the same until it reach this part, everything is same. You get the yo error, so the difference. And then you look for the and it's keep looping. When the yo error, the difference is very small, it's going to say reach the yo. So why we added 60 is because it's keep looking for the yo, and it will save the last instant it see of the object. So that's almost like 60. We tested different value. The most accurate value where the next object will always be at the field of view, it's the plus 60 to the yo error. We can modify it to make it look at, just take the value when the object is exactly at the center of screen, like the yo value, but this is a more simple solution for try and error. And it will say reach, save, and stop. So right now, it will increment the index, break the loop, and go for the next color. And the whole thing will repeat for the length of the list. And yes, this is our project lab 4 code.